Hello, my name is Jordan, and I'm going to be going over Exam 1. Part A of the first question is the integral of sine of 7x times sine of 5x dx. To solve for this, we have to split up the multiplication, and to do that we can use an identity. And you can see we have a sine times a sine, so we'll use this formula where A and B is 7x and 5x. So we can rewrite this as the integral of 1/2 times cosine of A minus B, which is 7x minus 5x, which is 2x, minus cosine of A plus B, which is 7x plus 5x, which is 12x, dx. Next we can split up this integral, and we can also bring out this constant. We'll have 1/2 integral of cosine 2x dx minus 1/2 integral of cosine 12x dx. And we can use u substitution, where u is equal to 2x, du over 2 is equal to dx, and for this integral, u is equal to 12x, and du over 12 is equal to dx. And we can go ahead, when we put du over 2 in there, we can take out this 1 over 2 and multiply it with our outside fractions. So we'll have 1 over 4 times the integral cosine of u du minus 1 over 24, the integral of cosine u du. The antiderivative of cosine is sine, so we'll go ahead and resubstitute the u values for both of these, knowing that the antiderivative is just sine. So we'll have 1/4 sine of 2x minus 1/24 sine of 12x, and we'll have a plus c, and that'll be our final answer. For part 2, we have to find the area between the curves y equals cosine x and y equals sine x, where x is between 0 and pi over 2. First, we can graph the curves, and y equals cosine x starts at 1, and at pi over 2 it's at 0, so it looks something like that. And y equals sine of x starts at 0, and at pi over 2 it reaches 1, so it looks something like that. And we're trying to find the area right there. To do that, we can find the intersection right there, which can be found by setting the graphs, the functions, equal to each other. So cosine of x is equal to sine of x when x is equal to pi over 4. With that information, we can find the area, which would be the integral from 0 to pi over 4 of the top function minus the bottom function, which is cosine of x minus sine of x dx, plus the integral of pi over 4 to pi over 2 of the top function minus the bottom function, which is sine of x minus cosine of x dx. Then we can go ahead and integrate. We know cosine, the antiderivative of cosine is sine of x, and the antiderivative of sine is negative cosine. So we'll have sine of x, negative times a negative makes a positive, from 0 to pi over 4, plus negative cosine of x minus sine of x, from pi over 4 to pi over 2. Then we can just evaluate. As we discussed earlier, sine of x and cosine of x both have the same value when x is equal to pi over 4, and that value is root 2 over 2 plus root 2 over 2 minus sine of 0 is 0 plus cosine of 0 is 1. We can add this to cosine of pi over 2, which is 0, and sine of pi over 2 is 1, minus, again, root 2 over 2 minus root 2 over 2. We can do some simplification. When we add these two values together, we'll have 2 root 2 over 2, and we can cancel out those 2's. So we have root 2 minus 1, minus 1 again right here, and this would be negative 2 root 2 over 2, canceling out the 2's, multiply it by a negative 1, would be a plus root 2, and the final answer would be 2 root 2 minus 2. For the next part, we have to compute the volume of the solid formed by revolving the region bounded by the graphs y equals x cubed plus 1, y equals 0, x equals 0, and x equals 1 about the y-axis using the shell, disk, or washer method. Step A is to sketch the region. I'll give plenty of room for the y-axis. So we know y equal to 0 and x equal to 0 is just our vertical and horizontal lines. Next, we can do x is equal to 1, and we can say that is x equals 1. And then y is equal to x cubed plus 1. Well, x cubed plus 1 crosses the origin and starts going up. So if we add 1 to it, let's say this is 1, and it would look something like that. So we'd be finding this area right here. But now we need to rotate this about the y-axis. So we can start off with our x equals negative 1, and then we can rotate y is equal to x cubed plus 1, and this will be the area again, rotated about the y-axis. And we can show that it's been rotated by giving it some 3D details, showing that it's a cylinder in shape now. So now we can say we want to find a random rectangle, say just about there, and when we rotate this, it looks something like that. So we want to find the height and the radius. Well, the radius would just be equal to x, and the height would be the function, which is x cubed plus 1. We can also see that the limits are just from 0 to 1. So we can say A is equal to 0, B is equal to 1, and this would be step B. For step C, we've already found the radius, which is equal to x, and the height, which is equal to x cubed plus 1. Now, we can set up the integral of the volume of the solid, and to do that, we need to find the area formula, which is a of x, which equals to 2 pi r times h. So, that's 2 pi x cubed plus 1. And when we solve for that, we would get 2 pi x to the fourth plus 2 pi x. Then we can go ahead and put this in a volume formula, where volume is equal to the integral from 0 to 1 of 2 pi x to the fourth plus 2 pi x dx. Now we need to find the value of this integral, and we can go ahead and find the antiderivative of this, and we'll actually pull out these 2 pi's out front. So it'd be 2 pi times the antiderivative of x to the fourth is x to the fifth over 5 plus the antiderivative of x is x squared over 2 from 0 to 1. Solving this, we have 2 pi times 1 to the fifth is 1 over 5 plus 1 squared is 1 over 2 minus 0 plus 0. So we have 2 pi times, and this is the same as 2 over 10 plus 5 over 10, which equals to 2 pi times 7 over 10, which is the same as 7 pi over 5. And those are our first two questions.